This is video 5 of our Aster Express series, and today we're going to cover running your first nPath query. The topics are going to include, we're going to define the use case, and we're going to go over the analytic process. We're going to understand our data source, and then we're going to run our first nPath statement, and we're going to go into an nPath deep dive so we can better understand the power and flexibility of nPath. So let's go ahead and get started. First of all, let's understand the point of view of what we're trying to do. I encourage you, if you haven't already, to view video 4 and understand how we built an Aster table and we loaded the data. This video is a prerequisite for this video, and it will help you establish how to build an object, a data object, and to load data into that object so that we can use this nPath query against that data. So, if I'm a digital marketing person and I'm working for the bank, I want to know what the client journey is online. I really want to know the efficiency and effectiveness of my marketing campaigns that go on my website so that I can see what customer and account holder behaviors look like. And I can really, what I want to do is I really want to understand and optimize my online marketing experience and my customer experience online. So to do this, first we are going to download Aster Express. We're going to load digital web data into a table, and we're going to run nPath queries and explore those behaviors. Again, please look at video 4 of this series, building an Aster table and loading data. That will help support this use case. So let's go ahead and get going. So before we get started, let's look at the general analytic process. It's really made up of 4 steps. Step 1, data load. Step 2, data preparation. Step 3, data analytics. And step 4, information delivery. Now, data load and data prep are basically the ability to build a data object and load that data into the system. I may have to serialize or modify my data to get it ready for analytics. And then I have to run my analytic, and this is where we're actually going to apply nPath to be able to get there. Now, you can apply any of the 120 plus analytic functions as well. And the idea is that I can rapidly change inside of this process with Aster. I can change my data load. I can go get new data sources. I can delete existing data sources. I can prepare that data differently for my analytic. And then I can apply multiple genres of analytics or multiple types of analytics to be able to get to the result that I'm looking for to support my use case. And then finally, we finish off with information delivery. And information delivery could be a Sankey flow visualization. It could be a hierarchy diagram. It could be the raw data itself. Or it could be a business intelligence report that comes out of a BI tool, and so forth. So let's go ahead and let's get going. So before we get going, we're going to review our data source. And our data source for our nPath query is bank web clicks. And bank web clicks is a table that has these 4 columns: a customer ID, a session ID, a page, and a date timestamp. So let's go ahead and take a look and let's understand a little bit about these columns. The customer ID is really the account holder identifier. So if John Thuma had an account there, I would have an account holder ID. The session ID is the web session identifier that I have as an account holder. So the combination of these 2 fields, customer ID and session ID, make up my unique session for that particular time when I'm online. And then of course the page. These are just the names of the visited page during that session. And we'll get into that a little bit later and what those mean and how they work. And it's really critical that we understand this field right here, this page field, because these are my events of interest that we're going to use to actually search inside of my nPath query. The date stamp is a field that contains the date timestamp of the click on this page. So every page that gets clicked has a date and a time that I'm going to use in order to be able to do my time series analytic against that data. So let's get a count of the total number of records in the table. And you can cut and paste this out or write this out yourself and do a select count star from bank web clicks. And you'll see that there's over 1 million records in the table. So let's go ahead and get going. Now, the events of interest, the web pages that are clicked by my account holders and my sessions, there are distinct sets of them. So you'll see here I set a distinct set of pages, and I got a count of those distinct set of pages from my bank web clicks. You'll notice that this is pure ANSI SQL. This is a group by kind of SQL statement. And so I can take advantage of the full power of ANSI SQL inside of my Aster environment. And you'll see here that I get a list of the distinct types of pages that are available inside my data. So I have an account summary all the way to bill manager enrollment. And this one is really important. This is what we're going to actually use later when we get into our nPath statement, because this is a conversion. What bill manager enrollment means is that they just signed up for a new product offered by the bank. So let's go ahead and get going. All right, so the next thing I want to do is I want to look at a set of account holders and sessions and the pages they were on and the date time they traveled those pages. And I can just type in this select star from public bank web clicks, order by customer ID, session ID, and date timestamp. I'm going to limit that to 1,000, so not to bring back all million records. You can see here I've got 1, 2, 3, 4, 5 sessions for the user 32. User 32 is an account holder number that had 5 sessions. And on that first session, the 0 session, they first went to the account summary, and then they clicked on the view deposit details, and they did that on this timestamp. And then their second session, they went to an account summary, they did a funds transfer, they went to bill manager form, and they went to customer support. This is their session for that. This is their complete web session for that set of transactions. And these two fields right here denote the key that identifies what pages were clicked on and when they clicked on them for that particular session. And that's really important. And we'll get to that here in a little bit. So, use case 1. Provide the bank's digital marketing department with the 40 most traveled web paths by every user. So we're not going to limit the number of users that we're going to go after or the number of account holders we're going to go after. We're not going to limit the sessions that they're after. We're going to go look at the complete population of account holders. So to do that, it's really simple. It's one line of SQL MapReduce. And the output of this is going to give me the list, the path. So you can see here, select distinct, path, and count star. And I've named that CNT. So the path is going to be the journey they took for that particular session from nPath. And nPath is really the SQL MapReduce function call. And normally you would see an ANSI SQL table here that the user would use to identify that this is the Aster function I want to use. The rest of this statement supports that nPath query. These predicates down here support how that nPath function call behaves. On-bank web clicks is my data source. And if you remember, in video 4, we used bank web clicks as our example to build out our table. Partition by customer ID and session ID. These two columns exist in bank web clicks. And the combination of these two fields represents the group of records that I use to create a partition of records that I'm going to search for. Order by date timestamp or date stamp. This also is a field within bank web clicks and denotes the time and the date of which they clicked on their session. So mode non-overlapping, we'll get to that a little bit later when we get into the deep dive of nPath. And then a pattern. A pattern is a regular expression type of statement that we're going to use to search through our partitions of records, our sets of records, and the dates and times that they come in. And those patterns are made up of symbols. And the symbol here is page. And you'll see this page right here is defined and it's put here. And what page plus means is that this must happen at least one to many times. And we're not looking for anything too advanced here. If you notice, this says true as page. This just says a page exists. So we're really not doing anything too elaborate here. It's fairly simple. And then we have a result clause. Result clause says accumulate page. This is a field within our data set of any page right there. This relates to that as path. And this path up here, or this path statement is really the same path up here that's in our results set. And then we have a group by one. So we're going to group by our paths. So we're going to look for everybody that's on that same path. And then we're going to get an order by two, a count of people that are on that path. And we're going to limit it to 40. So we're only going to look for the 40 most frequently found paths in our data set. So let's go ahead and take a look at review the data. So what the output is going to look like is this path column, which is in our results set. These are the two pages that were clicked on, an account summary and a FAQ. Over here is a count of the users that were on that path. and there are 2,854 users that are on this path. The top 18 paths are presented here, and then the next one is 2,830 paths that they went through the account summary page, then they clicked on the view deposit details and so forth. So this gives me the 40 most traveled paths. And let's go ahead, and what would happen next is we would show this to our digital marketing department. And they probably would have more advanced questions. They probably would ask other questions like, well, that's great, but we really want to know the power of nPath. So we want to know all the paths that lead to a bill manager enrollment. So remember, one of the events of interest is from our pages, our page types. This is a field within our bank web clicks table. One of those entries is bill manager enrollment. So these are events of interest, and we can use these to define symbols that can help articulate a better pattern to answer our question. So let's go to the next slide here. So we took our original code. So let's, first of all, the most traveled paths to a bill manager enrollment event. Okay, so we're going to take our original statement and we're going to add three things. We're going to make three simple changes. Step one, we put a comma here, true as page, so we're going to leave that alone. Page equals bill manager enrollment as BME, and this is a symbol we just defined right here. This symbol is then going to be used in step two as a part of our pattern. So page must happen at least once and is followed by this dot BME. So it must be followed by and end with a bill manager enrollment. And then we're going to change in step three here, we're going to change the way we accumulate our data. Page of any page, comma, BME as path. And as you notice, path right here is synonymous with path right here. So we made three simple changes to our SQL MapReduce statement, and now we have a totally different result. So let's go ahead and run that. And you can go ahead and run that inside of your Teradata Studio application. As you can see here, I actually have executed that particular query, and here are my results. And then I went over here and I actually ran those results again for this particular query. Let me go find that. Okay, it's right here. So you can see that everything ends in a bill manager enrollment. Then I have my count of my users that followed that path. So let's go into why that's important. So why is this important? Because I can now look at my account holder behaviors online and at a scale of millions of users and account holders and sessions. I can easily change my query. I can easily change where they ended up or where they started. I can traverse a complex set of analytic capabilities and behaviors online. And I can use this for things like attribution. What are the things that online caused people to do things or made them go a certain direction within my website? And I can look at that from an attribution standpoint to see if there is some sort of causal relationship between other marketing initiatives that I'm running from my organization that actually ended up in that new product offering and people enrolling in it. I can also use this to diagnose problems on my website. And this is really critical because sometimes in the path to online, you have pages that don't work, or you have a 404 error, or along a close of a deal or of an online transaction, I may have a disruption to my web flow, or I may have abandoned carts, meaning they were on their way to purchasing something, but they ended up not doing it. And this might give us some insight into why they weren't doing it. Maybe there's an issue with my my shopping cart process to close. Maybe it's too complicated, or maybe it's too, it just takes too long to do it. And there's reasons why people are getting off. This gives me the ability to diagnose those problems on my website. I can also feed this kind of details into a churn prediction model. So I can look to all the paths online that end up in an account close or a product close. And I can combine this data. This is just one of the data sets that I can use to combine with maybe an IVR system or call center notes, or I can look at the brick and mortar transactions. I can also combine this with other types of traditional banking systems that have data about my customers. By being able to use this and nPath, I can do things like find the golden path to a churn event, or I can generate a next best offer and find out, what should I be offering other people. And these are just some of the many types of analytics that you can do with nPath, and we're just touching the surface of what nPath can do. So right now we're going to take an nPath deep dive, and this is going to go into some pretty good detail here. So we're going to, first of all, what is Aster nPath? The nPath function allows you to perform regular expression pattern matching over a sequence of rows. With it, you can find sequences of rows that match a pattern you've specified and easily extract information from these matched patterns using symbols that represent the matched rows in the pattern. nPath uses regular expressions because they are simple, widely understood, and flexible enough to express most search criteria. While most uses of regular expressions focus on pattern matching in strings of text, nPath enables matching patterns in sequences of rows. nPath is powerful, and for simple example is very easy to use. But as we go through our nPath tutorial, we're going to go into a deeper dive into how it works and get started. So let's go ahead. But before we do that, I would recommend that you can read how nPath can be applied in real-world scenarios, and you can click through and go into this particular site on our Teradata magazine article. So let's get started. So if you remember from our previous use case, we provided the bank's digital marketing department with the 40 most traveled web paths. And we're just going to go ahead and we're going to decompose all the steps in understanding the nPath statement. So as you can see here, select distinct path and count star as count. This defines the result set of our query. So we're going to get the path of all of our users and their accounts and the things they did online for those sessions. And then we're going to get a count of those users across millions of those account holders and their sessions. From nPath, this particular statement right here tells the interpreter that we are using an nPath SQL MapReduce statement. And the rest of this is a set of predicates or instructions that tells nPath how to function. The on-bank web clicks, this is just a data object in Aster or through one of our connectors. It could be a table, it could be a view, it could be on the Aster file system that actually we're using as a data source. And if you remember in video 4, we built this data source and we populated it with data. So if you're an ANSI SQL person, you would think this is kind of strange, but select distinct path, and this is in the count would all be normal. From nPath is where this gets kind of odd for you. So instead of a table name or a view name or a data object name, we're calling one of our SQL MapReduce functions in Aster. The table name or the data object name is on bank web clicks. That's probably the biggest point of confusion when it comes to how our analytics work. Now, all of our analytics, all the 120 plus analytics that come with Aster function this way from analytic function name. And they all have their own set of unique predicates that helps them understand how they work. Let's continue. So the rest of this is partitioned by customer ID. So this defines the scope of the partition of input rows from which nPath uses to search for patterns. And because a unique account holder session ID is what we're after, and all the events that are included in that session is what we're actually searching for, the combination of these two fields defines our partition or our grouping of records. The order by date timestamp says for these customer ID and session ID partitions, order the events in them by the date timestamp. So that's important. Think of partition by as a grouping of records in a collection. So you can think of this almost like a group by statement. So let's continue. Mode. This is probably one of the more confusing aspects of it, but basically what this means is you have two options. Mode, non-overlapping, is the one we used, and the reason is because we want to match, once we find a match, we want to continue on. We don't want to reuse that pattern of those elements inside of my partition again. Overlapping would mean that we'd have like almost like a recursion of being able to find multiple paths in multiple dimensions of those partitions. So for our use, we're using non-overlapping, and that is right here. Okay, so the next thing is we're going to define a set of symbols. You'll notice that I skipped over pattern, and I'll explain why. The symbols are elements, so true as page. This page right here is synonymous with this pattern right here. Okay, so this is a symbol that is defined that we're looking for. And true as page means we're not looking for anything in particular. We want to see the data in its rawest form. And you can define a comma delimited set of these. You can define as many of them as you want. So I can look for other events of interest inside of this, and we would define the page right here, and we'd say page as bank manager enrollment. And we could look for any kind of type of symbol that we wanted to. We'd take that symbol and we'd make that an element of our pattern. Page plus means that this symbol must occur at least one to many times. So that's what this is all about. All right, excellent. So now we're into the pattern. And we kind of already explained this, but there is a, this defines the sequence of nPath of rows that nPath uses for its search. A pattern is comprised of symbols, so it's made up of these symbols. And you can use this pattern operation. We have different operators that are used, and we have a precedent of operators. So the dot, if there were two elements, it would be is followed by. So if there is a symbol of A dot B, this means A is followed right after a B. This delimiter right here, this pipe delimiter right here, this symbol right here, is an alternative. So A pipe B means A or B can happen. So it can be an either or an alternative type of operator. The question mark means that it occurs at least, or excuse me, at most once. And it only occurs one time. Not many times, not 0 times, but just once. And then the asterisk means that it occurs 0 or more times. And this is important because it means it doesn't have to happen. It can happen as many times as it wants to, but it can be 0 as well, which is really critical as we look at occurs at least once. So what this means is the plus sign means that that symbol must occur at least one time. So that's what we're using here, page plus. And if we had another symbol down here, like we did in our example earlier, where we defined the BME as the bank manager enrollment, we had page plus dot BME, which means that this page plus must occur at least once, it could be one to many, dot, followed by a BME event. Okay, and then we have precedence of operators, just like you would in mathematics with add, subtract, multiply, divide. It's the same kind of concept here, where the cascading operators are the first element, the dot. The alternative operator is second with the or. And then the frequency operators, the question mark, the asterisk, and the plus, are third. And then equal precedence, things that are equal, occur naturally left to right. So think of that as the same thing as what we would do with add, subtract, multiply, divide, and how that precedent works. These are the same kind of logic. Okay, excellent. Now, the rest of this is the result. And this is defining how we're going to use an aggregate function syntax to be able to accumulate our web page. So for this one, we're just saying accumulate, which means event 1 is comma delimited followed by event 2. As it relates to page, which is the data in our field, this is basically a column in our table of any page, and this page is uppercase, relates to this symbol right here, and we're defining that as path. So what we're doing is we're concatenating a list of symbols that satisfy this result phrase and then putting that into our result set as path. So that's how that works. And then we have a group by one, which says group by, collect all my similar paths together, much like a group by statement would work in ANSI SQL. And that's how that's working. So we're collecting all the similar patterns and looking at the entire population of our data set for accumulation of that path and of the people on that path. Order by 2 just means that this is the count, or CNT, of the people that are on, and the account holders that are on that path for those sessions. And what this is going to do is just give us, we're going to descend We're going to go from the most popular path, the most popular travel path from all of our users, and we're going to look for finally, we're only going to bring back the top 40 of those paths. And so, this is basically how our aggregate function syntax works, and there's a lot of different options you can use inside of this results set. With that said, this is just touching the tip of the iceberg when it comes to what you can do with nPath and what you can do with Aster. And for a full set of these instructions, I recommend, and this is contained in the Aster Express documentation, Aster Analytics Foundation, and you can go right into, and you can look at Chapter 4 here, at a detailed explanation of Aster nPath and all the other capabilities that come with the nPath tool, as well as the other 120 plus analytic operators that come with Aster. So I hope you enjoyed this today. Thank you very much, and have a great day.